familiar of all of these are two types. They are known as anticlines and synclines, and all being subjected to some geological setup. Sometimes we get an arching on sedimentary rocks, so we call this anticline. In other time we have down effects on the rocks and we start having concave surface, and this is from the force affecting the sedimentary rocks, so we call this syncline. This is two major forms of faults. They cover land of the Earth's crust ranging in area between few meters to tens of square kilometers in one locality, and in most cases, most of them are characterized by cracks and fractures. All types of faults are always subjected to what is known as recumbent folding. Most of the faults could be described by four structural elements, which include axial plane, lumps, axes, and fold faces. These are four elements very important to describe the fold. They are axial plane, lumps, axes, and fold faces. Folding. As for axial plane, it is defined as the plane which divides the fold into two equal parts, and it includes the axis, which is defined as the imaginary line of intersection of the axial plane with the fold surface or the earth surface. As you see, my dear students, we have axial plane and axis. Axial plane separating the fold in two equal parts, and this will make the third point here, which is the lumps. And when it separates the fold into two equal parts, it is an imaginary plane also. We got another imaginary axis which is called the axial plane. It's very important to notice if this plane is normal to the earth's surface, or it is inclined, or it is recumbent, and also it's very important to note that the axis is parallel to the earth's surface or inclined to the earth's surface. We got different types of folds for the changing of only the axial plane and the axis. It also defines the direction around which the sedimentary beds are bent, since any fold always contains of a succession of different layers, and each one of these layers has its own axis. Then the axial plane should contain all these axes. Concerning the fold faces, we can say that each fold contains two faces, one in the front and the other face on the back. If we look to the fold along the line which perpendicular to the axial plane. Folds are generally classified according to the following items. One of the bays with such fold elements might take a certain position in the field. As we said before, one of these elements or two of these elements will give us different types of faults. So we have to notice these elements carefully and to define the type of the fault. According to the shape of its outcrop in the field. Also according to the type and the nature of the tectonic forces affecting the rocks during the mechanical folding process. Now, my dear students, let's go to the second structure of these sedimentary structures here, which is faults. It's obvious from its name, it is a fracture cutting rocks masses and accompanied by movement or displacement of one side relative to the other side. So it's a fracture or cutting in the earth rocks, and this is accompanied by movement. In some cases the displacement, which may reach thousands of meters, may be in some cases the form of transitional or rotational, or transitional and rotational together. This is a kind of faults which are associated with major faults. They might be transitional, rotational, or transitional and rotational together. Faults, as in the case of the faults, have also their structural elements, with the most important of all is the fault plane, which is defined here as the plane along which the fractured rocks are displaced relative to each other, which implies the type and the nature of the fault, whether it is normal or reverse. This is one of the important structural elements for the faults, is the fault plane. The fault plane along which the movement is occurred and the displacement of one block to the another is occurred along this fault plane. But we can have normal fault or reverse fault. According, the normal fault results from transition and the resulting rocks masses occupying the hanging wall well displaced along the fault plane down with respect to those that occupy the foot wall. As you see, my dear students, we have a hanging wall. This is found above the fault plane, and also we have the foot wall. This is below the fault plane, and if the hanging wall is displaced down with respect to those occupy the foot wall, we will get a normal fault. But in the case of reverse fault, which result from compression, the rock masses occupying the hanging wall are displaced or moved along the fault plane, in this time up with respect to those occupying the foot wall. It's very obvious, moving the hanging wall up with respect to the foot wall block, this led to decreases the earth's crust. This is result from compression. When we got compression, the mass will decrease in its size. The shape of rocks will decreases in its size because of compression. As you see, my dear students, for the normal faults we have increasing in the earth's crust. This is result from tension. So the earth's crust and the rocks occupying this area will change according to the forces affecting on them. If it is compression, the rocks will be decreased in size. If it is tensional force, the rocks will increase in size and will get normal faults. We have other type of faults. As we have said, we have normal and reverse. Also we have thrust faults, where in these fault planes are more or less horizontal with high angle of depth. The fault plane and thrust fault with high angle of depth, and it's more or less horizontal fault plane. This is the thrust fault. Also we have another type of faults like grabens. These types of structure developed when the two hanging walls of the normal faults combine with each other in one rock block. As you see, my dear students, we have grabens, or a lower area resulted from having two faults beside each other and the hanging wall going down on both faults, so we have this lower area or graben. Also we have horst. This is in contrary to the grabens. Structures developed when the 2-foot wall of two normal faults combine with each other in one rock block. Also, my dear students, we have some structure features associated with faults. When we got faults, we got some features as polished surfaces along and near the fault plane, sometimes with various indicating the direction of the relative movement. As you see, my dear students, we have polished surface near the fault plane, and sometimes we have some variations or some striations indicating the direction of the relative movement. This is associated with the faults. Also we have occurrence of crushed rocks. Also we have sometimes calcite mineralization, and also mineral ore may be found occupying the fractures of the faults. This is one of the economic side of faults. Also we have hot springs, and water find their ways along the faults, and we have some famous hot springs like Hilwan, sulfuride water, Ain, El Sokhna, also on the western side of the Gulf of Suez, and also we have Hammam Faraon on the eastern side of the Gulf of Suez. Both are. Now, my dear students, we go to these giants. This is the third type of the secondary structures. These are tectonic fractures occurring different types of rocks without any evidence of apparent movement. It's very important to notice here that the giants are fractures like faults, but without any displacement, without any apparent movement. So giants are just fractures in rocks. However, faults, it's fractures, but we got displacement or movement along these fractures, and then we call it fault plane, since we have hanging wall and the foot wall and the fault plane. Now let's discuss the fractures or giants. Giants, the distance between giants surface varies less between 2 centimeters to several meters. The distance between the adjacent giants, the giants and the next one, it's ranging between just 2 centimeters to several meters. This depends on the type and thickness of rocks and the occurrence of the Earth's movements. In this respect, it is worth mentioning here that the ancient Egyptians made use of the giants' places in the constructing their tombs and obelisks. It's a very good point here to mention that giants are closely exhibited in the Eocene limestone of Jabal al-Muqattam east of Cairo and Giza Plateau, where the pyramids were built on. With the detailed study of giants in an area, one can determine the direction of stresses that affected these rocks and the associated geologic structures. Unconformity structures. This is the next structures we talk about. We have surface of unconformity considered or non-deposition surface, clear and distinctive, separates between two different layers, the two groups of lithofacies, and demonstrates the absence of sedimentation time for periods of up tens of millions of years. So it is time of non-deposition. It's very obvious in the sedimentary rock. We can recognize some erosional surfaces separating between two types of lithofacies. We have accession of the sedimentation. We might have regression of the sea level. We don't have any marine water to continue sedimentation, so we have this type of surfaces. It is unconformity surface. Unconformity structures. This is the next structures we talk about. We have surface of unconformity considered or non-deposition surface, clear and distinctive, separates between two different layers, the two groups of lithofacies, and demonstrates the absence of sedimentation time for periods of up tens of millions of years. So it is time of non-deposition. It's very obvious in the sedimentary rock. We can recognize some erosional surfaces separating between two types of lithofacies. We have accession of the sedimentation. We might have regression of the sea level. We don't have any marine water to continue sedimentation, so we have this type of surfaces. It is unconformity surface. We have several witnesses for the unconformities. We have evidence which shows that there is a mismatch between the two types of the lithofacies. We have mismatch between the lower and the upper layer. The second evidence here, there is a layer of gravel or rounded gravels located beneath the surface of the unconformity directly. Also, we have another evidence, which is the sudden change in the fossil content between the different layers or the different classes rely on different changes in environments. So we have different types of fossils. The third evidence here, we have different classes. We have different slopes. We have different slopes of the both sides of the surface of unconformity. The lower and the upper layers, they have different slopes. So this is an important evidence to recognize the unconformable surface or the unconformity surface. Also, we have the existence of geological structures or veins in one of the sides or one of the lithofacies, and they do not exist in the other side or the other lithofacies. My dear students, we come to the end of our today's program. I hope you got benefits from our today's episode. Until we meet next time, have my best wishes and goodbye.